250 volts on it, and seeing that they're rated up to 2,500, it's a good job it wasn't plugged into a transmitter.
Yeah. Don't know what that play is in here. I'll have to find out. Get rid of that one. So, right, I'm ready. How are you? Are you ready?
I am.
Everyone's ready. Record, yes.
Yeah.
Right, now I have something of an enigmatic amplifier to show you. It looks very solid and very professional. A pair of KT66s, 2 double triodes, both Marconi with their labels. Looks as though it hasn't had a lot of use in these valves because the labels are still on, including on the KT66s. There's a GZ34 which may or may not be the intended original type. It could have had one of the bigger ones, GZ32, 33, possibly 5U4 or 5R4. They boxed up the inductors, which all looks very neat, but means that we don't know who made them because these don't actually come off easily. When one looks at it, 4 boxes, not 3, so what's going on here? You might suspect that this is a choke input filter with 2 chokes. If so, you're half right. 2 chokes, yes. Choke input filter, no. Someone likes to think this is a Williamson. It isn't, but it is triode connected. So on the front here we've got a Jones plug which has been disconnected and a jack socket that you can guess is not original. Have to be careful with this table because this is heavy. Handle either ends and it needs it. So, originally, be a bit careful with the balance there. I think I'll hang on to it. Originally another Jones plug for the outputs. They put 4mm terminals on, 2 fuses. I think that little bulb in was the original. You'd expect it to be the big type. And another connector not connected. Now, I need to turn this over. This is not fun. It is heavy, and even with the handles, there's a lot of pressure on one's fingers. So what have we got here? Can you get a decent shot in there? Very professional, very nicely wired, all right angles, all laced up cables. But there were a couple of errors in here. But starting, not electrolytics in the main smoothing. There are 4 of these TCC viscanols, 4 microfarads each, wired into 2 pairs of 2. These are paper, not electrolytic. With a big choke that will give very good smoothing. And we can see that one of them is 20 Henrys at 40 milliamps. That is not the main choke. The main choke, is that one, and that is 10 Henrys at 200 milliamps, which is more like it for the output valves. Now, was this made professionally, or is it someone's home build done very professionally? There's no name on here. And there are things about it that lead me to believe that this was either a prototype, a one-off, or a very short production run. It is certainly professionally built, but that could be by a very good amateur or a professional doing a home job. The output transformer is multi-tapped. Now you wouldn't use that in a production run because you're paying for taps that you don't need because you know what anode impedance is needed. It's also multi-tapped on the secondary. This will drive volt lines as well as straightforward 4/8/16 ohm impedance. It's wired for 16. It gives about 19 watts output, which is what you'd expect of triode connected KT66s. The maximum anode impedance on here is 6K, which is actually rather low for KT66s if they're used ultralinear or pentode. And one could double the output of this amplifier approximately by rewiring it as ultralinear or pentode, and one can wire it ultralinear simply by moving the anodes to the 6K. Actually they would want 6.6 or 7K, and then moving the screen grids to one of the other taps depending what percentage you want for your ultralinear. It's built on the bus bar principle. That is, the earth connections do not go to the chassis directly. They go to a wire, it's a very stiff wire, which is insulated all the way round. Except they made an error. There are three electrolytic cans, and they are marked can not isolated. Two of them have a high resistance between the negative terminal and the can. The third one is a short circuit. So when I measured between the bus bar and chassis, I found a short circuit. So what I did is I took it out and I wrapped insulating tape round it and put it back in. There should be no significant voltage between, and that is a perfectly legitimate thing to do, but it should have been done by the guy who built it. Bit suspect that. The actual bus bar is supported on these hollow ceramic devices, and I have a strong suspicion they were not designed as insulators. My belief is that they were actually ceramic variable capacitors originally, in which case they were high quality and would have been used possibly up to UHF. Anyway, having cured that problem, I then put a resistor of 100 ohms between the chassis and the bus bar. If you don't do that, you tend to get a voltage, a kind of static voltage due to the capacitive leakage in the mains transformer, and if you touch the chassis and its earth rail, you can get a shock off it. So whilst the only place where the earth and the system earth should be joined is the input connector of the most sensitive input on the preamp, it is a good idea to have an earth lift resistor. You won't get a hum loop that way, unlike if one directly joins the electronics to the chassis, but one also doesn't get the static voltage. Something else I changed. There was no earth connection between the chassis and the mains. Not safe. You don't rely just on the insulation in the mains transformer. But apart from that, it's very nice. I checked the value of some of the resistors and they have drifted, but I didn't think it was worth replacing them. You can rely on one job to be done in an amplifier like this. If you can see the yellow capacitors, there are 4 of them. The originals were high quality. They were the ones in the metal tubes and they were pan-climatically sealed. But unfortunately at this age, just like the cheaper ones for consumer equipment, they are leaky. And I did actually, out of interest, measure the voltage on the output valve grids, and they were both decidedly positive before I replaced them. That must always be done, otherwise it will sit here drawing excess current. At the best it will shorten the life of the valves, but the distortion goes up, but by the time people realise there's something really amiss, they may have ruined the output valves, and indeed they may have either burnt out the output transformer or the mains transformer. So always replace those coupling caps. There were 2 others in the signal circuitry, and again they would have been leaky, only slightly, but it's enough to positively bias the control grids of the connected valves. The distortion will go up, and also the output power will go down, because sooner or later it causes clipping. So that's the job you always do. It's not generally a hard job. These capacitors to the output valves are on the expensive side because of the high HT, and in case it is used, and originally this has solid state rectifiers across the valve base. With those or a fast heating directly heated rectifier, the HT is going to be about 600. So one wants a fairly generous margin above the 600. Now, I said this originally had solid state rectifiers. Someone put BY127s across the base, and they quite possibly added these 50 ohm 10 watt resistors. I suspect they're not original, partly because that style of square and white resistor is relatively modern. This amplifier, well, it's post-war, I wouldn't like to date it, and unfortunately there wasn't a date on the electrolytic can, but it may have been, well, have been built in the 50s or 60s. Very interestingly, one side of the heater to the rectifier only was wired. The sensible conclusion was this was built with a valve rectifier because it's almost certainly older than silicon rectifiers are anyway, and that when two BY127 diodes were put in there, they disconnected one side of the heater, partly because they'd wired across the two heater connections. However, on examination I found that the pins were all wired the wrong way. They were offset by one pin. So if I had plugged the rectifier in, not only wouldn't the heater have come on, but the anodes wouldn't have been connected either. So all four connections had to be redone, which was quite a lot of fun because this is a very old valve holder and it was oxidised and it really didn't want to take solder. The trick there is partly to use red jelly flux and paint that on, but you also have to rub your iron up and down on them. If I'd known how awkward it was going to be, I might have got in there with sandpaper and sanded them first, but it's not particularly easy for access. Very nicely made boxes. It would be very nice to see who made these transformers and what they look like, but you can't just take these screws out and lift them off. And I undid the four big ones underneath and you still can't pull them off. It meant unsoldering the transformers, and I decided against that. That, I think, concludes what I want to say about this, except that it's quite good as a heater in the winter, because being a Class A amplifier, that is something I should have said. It's Class A Triode connected KT66s, so they draw the full current the whole time, which is about 150 milliamps at 450 volts. So that's about 70 watts of anode dissipation between them, plus the other valves. So if you're worried about your electric bill, this is probably not the amplifier for you.